that Rolle's theorem applies. And that's exactly how you do your assignment. You check, you write those three statements. If one of them is not satisfied, you stop and you say Rolle's theorem does not apply. Okay? If it's not continuous, I stop. Rolle's theorem does not apply. If it's not differentiable, I stop. Rolle's theorem does not apply. If these two values are not equal, you get to this point and they're not equal, Rolle's theorem does not apply. If you get through all three and they're true, then you say Rolle's theorem applies. Good? Okay? And what does Rolle's theorem guarantee? Okay, so Rolle's theorem applies and, okay, that means that at some point C in that interval AB, the derivative has to equal to, what do you think? To 0. Okay, so you can see my writing here, right? Let's say I'm going from here to here. Okay, somewhere between here and here, the derivative has to equal to 0. Would that be true?
Yes.
Yes. Is it continuous?
Yes.
Is it differentiable? Yes. There's no places where it's not differentiable. What would those places be? Wherever I have vertical tangent lines, right? Or wherever I have what? Poles, that would make it not continuous. Not all points of inflection, but some of them. At cusps. Okay? So none of that occurs here. Right? Does the starting point equal the ending point? Yes? Okay. So therefore, somewhere in between there, the derivative should have to equal to what?
0.
To 0. And it is true. Okay? And that's what we're going to explore right now. So f prime of C should equal to 0 at some C in the open interval AB. Okay, so the endpoints are not included, all right? It has to be in the open interval. Got it? So let's explore, okay? Using the graph on the previous page from 2 to 14, let's see if Rolle's theorem applies. All right, so we're only looking from 2 to what? To 14. So start off with the first one. Is it continuous in that interval?
Yes.
Yes. Is it differentiable in that interval? Yes. Okay, there's no cusp, there's no holes, there's no vertical tangent lines, nothing. Alright, does f of A equal f of B?
Yes.
When I go to 2, I'm at 5. When I go to 14, I'm at 5, right? Alright, so therefore Rolle's theorem should apply.
Yes.
And that means that at some value in between 2 and 14, the derivative should equal to 0. Is that true? What is that value? 8. Alright, so now let's write all that down there, since we already put. So 1, f of x is continuous on the closed interval 2 to 14. F of x is differentiable on the open interval 2 to 14. F of 2 equals f of 14, and it equals to 5, I think, right? That was the value at 2 and at 14.
Yeah.
So those three things are true. We can say Rolle's theorem applies. So what must be true? F prime of C has to equal to 0 for some C in that interval. What is the C? And is C in there between 2 and 14? At least one. Yeah. There could be more than one.
It wasn't a straight line.
Yes. If it was a straight line, then it would be all of them.
Rolle's theorem.
Cool? Alright, how about between 2 and 8? So 1, would it be continuous between 2 and 8?
Yes.
Yes, because we already know it's a parabola. You have to write all this down, okay? Is it differentiable from 2 to 8? Yes. Open interval 2 to 8. Number 3, does f of 2 equal f of 8?
No.
What's f of 2?
5.
5. What's f of 8?
11.
11. So they are not equal, so it didn't satisfy the 3 conditions, so therefore what?
Rolle's theorem is
Rolle's theorem does not apply. Papitas?
Yeah.
Kindergarten stuff? The hard part is to remember the closed interval and the
Differential.
open interval, okay? Don't mess that up. Alright, wanna try one? So for each of the functions below, determine whether Rolle's theorem is applicable or not, then apply the theorem to find the values of C guaranteed to exist, okay? So only if it applies are we gonna find the values, obviously, right? So let's look at this first one. First thing we check for is what? Continuity. So is it continuous?
Yes.
Why?
Polynomial.
So g of x is continuous on the closed interval -3 to 0. On the AP test, you don't have to say why, you just have to say the statement, okay? So we know it's continuous, but I'm gonna write why. Because g of x is a polynomial. Second thing we check for is what? Differentiability, okay? So to be able to determine that without a graph, I want to look at the derivative equation first. Okay, so what is my derivative? What's it gonna be?
18.
Okay, so now that I can see the derivative equation, I know that the derivative is a polynomial, so therefore I know that it's continuous everywhere, right? And it would be what? Also differentiable, right? We're not gonna have any places where it will be undefined. So we're good. Okay, if the derivative was a fraction, then would there be places where the derivative is undefined? Wherever the denominator equals to 0, then you would have to check that number to see that that number is not in the interval. Then you could keep going forward, okay? So you gotta be careful. Alright, so since this is good, we can say g of x is differentiable on the open interval -3 to what?
0.
To 0. We can move on to the third checkpoint. And that's that g of -3 is equal to g of 0. Plug in 0, what do you get? 0 minus 0 is 0. And then plug in -3. -3 squared? 9 times 9? 81. -3 to the 4th? 81. So 81 minus 81? 0. So is that good? Alright, so therefore we can say what? Rolle's theorem applies. So g prime of some number c should equal to what?
0.
To 0, and we need to find it. Do we already know g prime?
Yeah.
We equal it to 0?
Yeah.
My God, this is just like finding critical numbers again, right? Okay, so let's see if we can do it. So 0 equals 18c minus, or c cubed. Can we solve that? What can we take out? 2c? What's left? 9 minus 2c squared equals 0? So we said each factor equal to 0, we get c equals 0 over here. Over here I'm going to do minus 9, then divide by -2, so that gives me c squared equals 9 over 2. Are we okay that I didn't show that step?
Yeah.
Say yes? Okay, thank you. And then the last thing to do would be to what? The square root. So c equals plus or minus what? 3 over radical 2. Alright, so now which of those c values are in the given interval? The open interval. Okay, that means they cannot be endpoints. Which are the proper c's that I need to pick? Can I pick 0? Why not? It's an endpoint. Can I pick positive radical 3 over 2? No, because it's between 0 and what?
You think negative?
-3. Okay, so my only c value that is guaranteed in this particular interval by Rolle's theorem has to be what? -3 over
2.
radical 2. Do I have to rationalize?
No.
No. You could mess up trying to rationalize and then lose the point. Okay? only on multiple choices where you need to rationalize or make y equals on the equations of lines. Anywhere else, just stop. Okay? Good? Kindergarten stuff? Alright. Try the next one, number 2. What do we check for first?
Continuity.
Continuity, okay? Where is this function continuous or not continuous? What would be easier to find? Not continuous? Okay, where is it not continuous? X equals -2, because that would give us a denominator of 0, and every time we divide by 0, a cat dies, so please do not do that. Okay, it's one of the 10 commandments, thou
Now you
shalt
tell
not divide
me.
by 0. So,
Now you tell me.
so we get x equals -2, is -2 in the given interval?
Yeah.
Yeah, so it's not continuous in that interval, therefore,
Both here is not.
perfect, we can stop after the first step. So let's say g of x is not what? Continuous at x equals -2, which is in the closed interval -4 to -1. Therefore, Rolle's theorem does not apply. Papitas? Got it? It's too easy? Alright, we're gonna stop there, and on Monday we'll continue with mean value theorem, okay? The nice and pretty expressed way of Rolle's theorem is over here on the next page. If you wanna read it, it's basically everything that I told you, I just put it into steps to make it easier for you to work, okay? That's exactly what you're checking. Three conditions must be true. Say it applies, that implies that the derivative should equal to 0 at some value. What are the three things that must be true?
Continuity.
Continuous on
Closed interval.
closed interval AB, differentiable on
Open
open interval AB,
F
F
of A equals F
must
of B.
equal F of B, right? Something must happen there, could it be a straight line too? Yes, right? Okay, so that implies that F prime of C should equal to 0
That's the point.
for some C on the open interval AB. So the C cannot be an endpoint, okay? Got it? Kindergarten stuff?
Yes.
Alright, let me give you your assignment. You have time to work on it now, so take advantage of it. Got about 30 minutes. Yes?